Algebraic expressions. Algebraic expressions is a weird looking word and it almost matches how weird the problems look. The name of it looks kind of weird. The problems look kind of weird. Okay. A key player, you're being introduced to something called an expression. Say expression on 2, 1, 2. Expression is a combination of numbers. We might call them constants. Fancy term for number. Mathematicians like to change around the words to sound pretty smart. Constant is a number. It's just a plain number. So you might have numbers. You might have variables. Say variable on 2, 1, 2. Variable is another weird word. You haven't really seen a variable. Maybe like your 5th grade teacher tried to advance you and show you it, but this is really new to us. And of course, you need a sign. So addition, subtraction, multiply, divide. A lot of really weird things happening. Look at example 1. This just looks bizarre. Like never have I seen an X. Maybe a time sign, but not just an X. X is a variable. Write X equals and put a variable. You are entering the realm of algebra a little bit, and you're kind of peeking into 7th and 8th grade math and a ton of high school math. High school math lives with variables. They have X for variable, they have Y for variables. A variable means there is a number that is missing. You have some number that they're calling X, but there's actually a number that it equals. Some number is X, and in this problem, all of today's lessons, they're going to tell us it's 5. So they say X is equal to 5. This entire thing, underline 3x minus 14, is called an expression. Point to it and write expression. An expression is a math problem without an equal sign. Notice how there's no equal sign here. There is an equal sign when it says what x is, but not on the main problem. So let's rewrite 3x minus 14, make it fairly neat so we can work with it and see what's going on. Okay, so you have this mysterious x, which they're being kind of nice to us, and they say x is what number, whole class? It's 5. They say x equals 5. So you're going to just look at the x and kind of replace it. In your mind, you think 3 times, not x, but 3 times 5. And when you have an x next to a 3, it always means multiplication. This is 3 times an x. So let's try to show what that looks like. 3 times a 5. I'm not going to put a multiplication sign like this. Why not? Why wouldn't I put 3 times 5? Turn and talk to your partner, go. 5, 4, 3, 2, 1. Mason, why wouldn't I do that? Yeah, it's kind of a big no-no. Like we're gonna kind of stop writing multiplying like an x because it looks like an x. And so instead, we're just gonna put in parentheses because we know 3 next to parentheses is multiply. So do 3 parentheses 5. And then attach that negative 14. There is our simplified problem. Brayden. Yeah, this is an option too. Let me write it to the side. You could do 3 and then that dot 5. That's the same thing. I'm going to kind of push you to use parentheses. They come up more often than not, and when we go later on into equations, parentheses are kind of our go-to with multiplying. So you could do 3, parentheses 5, or 3.5. They mean the same. For this lesson, I'll accept both. Let's multiply it or subtract. What do I do first? Go back to the pyramid of GEMDAS. Multiply or add first or subtract? Chad? Okay, 3 times 5 is what, whole class? Okay, and then rewrite that 14. We're going to layer it, go down very, very clearly, very neatly. 15 minus 14 is 1. So this expression, when x equals 5, is the number 1. You just evaluated it for x equaling 5. That is what this means. Let's look at B. Evaluate z to the second plus 8.5 when z is 2. They tell us that z is 2. Where do I put that number 2? Where does it go? I'll take a silent hand. Justice, where does that 2 go? Yeah, and notice how there's an exponent. Whenever you have a number that z equals and an exponent, I want you to get in the habit of putting it in parentheses almost all the time. You will put that number in parentheses. You'll see why it changes in just a minute. Two to the second power plus 8.5. What does 2 to the second actually mean? What does 2 to the second mean, Daniel? It's 2 times 2, which is 4. Anything to the second power is itself times itself. 2 times 2 is 4. So where does that 4 go, Daniel? Okay. You just did exponents. There's no multiplication. There's no division. Go to addition. 4 plus 8.5. Let's use some scratch work. Remember when I add a decimal, we build a snowman. 4 is the same as 4.0, and your answer is 12.5. It is adding. So when z squared plus 8.5 has z equaling 2, you're going to get a number that's 12.5. 2 more. What is different about C? Turn and talk to your partner. Go. Three, two, one. Something that they just threw at us that looks a little weird. Cameron, what is it?
There's two variables. There's y and z.
Thanks for using that vocab. They have 2 variables in here. And if they give you 2 variables and they say evaluate, they better give you 2 numbers. And they do. They say y is -6 and z is 5. So let's rewrite the whole expression and then start substituting. Well, y was -6. Put -6 in place of y. Z is 5. Put 5 in place of z. And this is actually a simpler GEMDAS problem. There's just addition. Give me the answer. I'll let you work it out, so then raise your hands. Still go step by step. What's my answer, Jackson?
1.
You got it. -1 plus 2. Go back to good guys, bad guys. The good guys are winning. Last one. This is one of the harder ones that you'll see today unless you get to gold. We have P, Q, and P. This time, they have a variable listed 2 times in the expression. If they do that, you're just going to place the -6 twice, there and there. -6 out of parentheses. The Q is a -3. Then they have a -P. Watch what happens. There's a negative sign. And a -6. Why are there 2 negative signs? You can do parentheses, it's fine. Why is there 2 negatives, Reese? So there's a minus sign here. Do you see that? And then what was P equal to, Reese? There's a -6. So you have a minus and a -6. You need to include both. Oh boy. Let's tackle it. We're going to group first, do the parentheses, simplify it a little bit. -3 divided by a -6. Let's simplify the negative. Giant plus sign, rewrite it. -3 divided by. Ooh, did I do this wrong? Whoa, back up. Help me with my blender, silent hand, and walk me through it. I forgot something here. Chad, what did I do wrong?
So I was like thinking, I was like, wait, how did I get that when you got that? So
Yeah.
you did -6 parentheses, and you should have done -3 divided by +3, and then
There's what I
-6.
missed. Thank you for fixing that. Do you want to mark a blender, Cameron or Chad? Yeah, I forgot that 3. Be really careful and really precise in your problems today. So negative 3 divided by 3 plus 6. Let's keep chipping away. Some problems will be easier like C. Some will have a lot of steps like D. Sierra, what am I going to do in the parentheses? Division or addition? Divide first. Negative 3 divided by 3 is what, Lauren? Negative 3 divided by 3? 3 divided by 3 is what? It's a 1 and it's negative. Same good, different bad. Bring down the 6. Jackson, what is negative 1 plus 6? Okay, bring it down. You finally get negative 6 with a 5 in parentheses. When you simplified the inside parentheses to a single number, you know you have simplified it as much as you can. And we're on to the outside. Negative 6 times 5 is negative 30. This was a lot of work. Notice how I set it up. I'm layering it, I'm writing it neatly, and it looks like a really clear step-by-step problem to get my answer. Take out a piece of lined paper. Look at your packet and notice there's a few weird things going on. Number 1, 2, 3, and 4 look like they don't really have a number for y, except for this first one. If they give you one value of y and then list a set of problems, you're using 6 for y for everything in here. So you're going to just take the 6 and place it in every problem for 1 to 4. For numbers 25 through 36, a few weird things. The numbering is off, just ignore it. You're going to go from 4 to 25, just numbered weird. You'll live. And notice what they give you here. They're going to give you 3 options. You're going to find what variable is in the problem and use that number. So for 25, do I need to even look at the B and C? No, because there's no B and C here. For 26, you'll look at B. For 27, you'll look at C. What else do I want to see? Gold is a little bit tricky. I want you to start on at least bronze for 10 minutes before you switch off. This is a really new concept for us. Make sure you talk with your partner. Make sure you're checking your answer on the back of the packet. 10 minutes. Go. And you can switch either way. You have a little bit of room in 1, 2, 3, and 4. When you get to 43, I need this definitely to be on lined paper. Do not try to crush 43 through 51 on your page. Yeah, right. 43 I need online.